The way I would like this to work is while I describe some of the things we implemented and described in the paper, that if there is any question, please interrupt me and we can go in further detail. The paper is long, so I will try to help those who want to read some section or some other to navigate it. The idea is that there are multiple motivations for extending the syntax of Smalltalk, and those come from different levels of abstraction. So, for instance, if you have a self-hosted VM implementation of Smalltalk, you need a way to express very low-level things like assembly code, for instance. And if you are doing mathematics, then you need some other kind of extensions to mimic the mathematical notation. And if you are doing, I don't know, a web server and you want to render JavaScript code, then you need yet another kind of extension for those things. The idea of Smalltalk is to be the place where you capture knowledge. And by capturing knowledge that is everywhere in your project, you end up always creating knowledge. But it's important to recognize the knowledge you are trying to mimic and represent when you read your source code. So let's go through some examples, and then I will try to make sense of all of these that could be chaotic at first glance. One thing, if we go to the mathematical kind of projects in mathematics, is that having Unicode helps a lot. So, for instance, if we have the superscript 2, we can change the square message with just x squared. So, right, like in mathematics. So, for instance, if you have an equation, this is from physics, from cinematics, the position at some time t is the initial position plus the initial velocity times the time plus 1/2 of the acceleration by the time squared. So if you can write these in Smalltalk, you have a closer view of what you are modeling, because this is how you will find in physics books. In another kind of application, sometimes you have to deal with JSON structures. And in that case, you would like to be able to represent these kinds of notation. So how to do that? And in the low level, it's not just Smalltalk. It could be also the bytecodes that display themselves in a way that makes sense for the reader. How if we turn that read-only display into something we can also write? So let me give an example. So for instance, one very popular message is factorial, right? So if we go, it's easy to go to the Wikipedia and see the definition, etc. And we will find, which is not the one we use in Smalltalk, where there it is, where we have to write I don't know, 5 factorial, right? And get the result. But for a mathematician, it's easier it's more natural to write like this. So we need also to extend sometimes the notation for allowing Unicode not Unicode, sorry, unary symbols, like in this case. So the paper describes how to do that. For instance, how to implement the JSON notation, how to implement unary selectors, how to implement prefixed unary selectors like the ones we use here for logic. And that has several implications, because once you start and expressing your model using the notation that is natural for that model, you change your mind and start looking for ways to mimic that in other places. So for instance, in mathematics, you have the gamma function, right? This is a very famous function that you can find everywhere in the literature, but of course is known to mathematicians, but it's a function. So in Smalltalk, a function is usually implemented as an object, like I'm showing here. So the idea of having a function is that in the case of Smalltalk, we are used to create, for instance, an instance of this function. Now I have the function, and then I can say gamma value, I don't know, 5, and this will give me a result. Okay, but this is in contrast with the mathematical notation. In mathematics, a mathematician will write this Greek letter, uppercase gamma, and will say gamma of 5 rather than gamma value 5. Okay, so this is not Smalltalk syntax, but can be turned into a syntax, into a valid syntax. Gamma function new. So in this line, I'm just using Unicode, but in this line, I'm changing the syntax, right? And the syntax of Smalltalk is just a way to replace this expression between parentheses with underneath with the value message. So so there are certain things you can do because syntaxes that make no sense or are forbidden in the Smalltalk language actually have a collision with the way that the Smalltalk syntax is validated. So instead of, so there are, if you take advantage of the grammar holes, I'm looking for that, then you can insert new things where there is something that is not well defined. So there are other things you can do. For instance, you can write, let me see here. So in this case, for instance, I'm using the Smalltalk array definition with curly braces to mimic JSON notation, or here I'm using tags to express Smalltalk code, assembly code, like here. So in this class, we have lots of assembly code written in assembly. And what happens is that when the Smalltalk parser or compiler hits these tags, it switches to assembly parser and parses that expression in assembly, and then you have expressed a good way to include assembly, to express assembly code in Smalltalk. So the idea is that there are many things that we can do to extend the notation without having to ruin or complicate the current compiler and parser. So for instance, in Smalltalk, we have unary messages, binary, and keyword, right? So the first thing I show with the gamma function is we can add just a new a new kind of messages, which is the function that reads what comes in between parentheses. And it's just adding one line to a regular to the existing parser, and then one node and just one method to support the creation of these new nodes. It's not changing the syntax in any way. It preserves everything we had, but adds a new possibility. And the same idea can be applied in other cases, like, for instance, adding pragmas that allow to say to the compiler, what comes next is not a Smalltalk system syntax, is, for instance, JSON syntax. And you can write JSON code here. And you can do the same for other languages by introducing these tag nodes that, again, require only adding a line to the parser, and then some new parse node to support the new kind of node you are creating. So the idea of using these grammar holes opens a lot of space creates a lot of space for adding new expressiveness. So for instance, in this case, here, instead of JSON, I have a JavaScript, and this tag is telling the Smalltalk parser what comes next is JavaScript code. So you can use that and have it formatted and compiled and validated and pre-printed, etc., which gives you a lot of confidence in your code. The alternative would have been to put a string here, but the string, you don't have senders or implementers, no pre-print, no validation, etc. Here, there is another example with Pascal code. Again, this is a Smalltalk method, and if we put Pascal code under this tag, then the compiler will switch to the Pascal compiler or parser and will produce this validated code. Other places where you can apply this is for every method in the system. You can, so for instance, here is a comparison between what a programmer would do if they have only a string and want to produce the JavaScript code with a string, and here is the same but in JavaScript format. So you can tell the difference. This is giving the programmer much more feedback than just a monocolor string, right? And whatever doesn't matter the method, you can always print its bytecodes in some intermediate representation form. And so another thing you can do is to let this representation to be also a programming language. So the idea is with the appropriate or pragma, you can tell the Smalltalk compiler what comes next is in this language of the bytecode representation. So these results or transforms a read-only representation into a representation you can write code with. And this is very important in the case of a self-hosted system, because there is a tension between the high and low levels, and you need to find the minimal amount of tweaks so you can express low-level code in Smalltalk, right? So there is maybe, so for instance, here I have an example of the high bit method in Smalltalk. Here is one possible implementation. There are many implementations for which having a small integer, you can get the highest bit it has. But here is one. All of them are quite large, like this one. But expressing this in an intermediate language is it's very short, because this is just a bytecode that expresses itself. You can compile this is actual code, and get in return the machine code representation of this very same instruction, which is in the case of Intel that I have here is BSR. The rest is just transforming the number of bits into a small integer, a tagged integer, and doing something with the frame. So
we have 2 minutes.
Okay, so the paper also includes a whole section where we applied all of these features, like tags for creating, for introducing or injecting a new language, in this case Smalltalk, unary symbols, Unicode, etc., etc. So for like here, for instance, we have a prefix selector where the symbol comes before the receiver, and many other things that create a very tight connection with the Z3 library. So for instance, we can end up showing this this table where we can compare in an example Unicode Smalltalk with the prefix unary selector, the negation, with Unicode selectors, this in ANSYS Smalltalk would have been something like this, which is, this is exactly what a mathematician or logician would write. This is what a Smalltalker would write. It's not exactly the same, and this is in C code. So, so the paper presents several extensions to the syntax, takes advantage of Unicode, and also introduces a way to tag external code that can be brought into existence inside Smalltalk, which we use a lot for the very low level stuff of the self-hosted Bismuth. That's it. If someone has any question, or I can clarify whatever is asked.
Thank you very much. We have two questions here. I think Juan first, if you want to go.
Okay, thank you. Well, great work, Leandro. Thank you. My question is, when you showed negation, that, if I got it correctly, looked like a unary message with the prefix syntax. But when you showed the gamma function, if I got it correctly, that was a global that was getting the value message due to the parentheses. If this interpretation of both cases is correct, couldn't you have used the prefix syntax for unary messages in both cases? I mean, could gamma, instead of being a global, be a selector and a method?
Well, gamma is actually not a global; it's a local variable in the workspace. So if I define gamma here, sorry, gamma, like the gamma function, new. This, well, this is just I don't know. This doesn't have to be a global. I'm so I have,
That's
an N.
no, that's because, oh yeah.
oh no. But yes, sorry.
Because
No, it's okay. So this gamma is not a global. This Greek letter gamma is not a global. It's just temporary in this workspace. And then I have this notation, which is equivalent to say gamma value 5, like this. Okay.
Yeah, the question was why not use a selector like in negation?
Well, because in this case, gamma is not a method or a function, it's an object. So you have to distinguish between f of x when f is a method and when f is an object. So I'm not proposing selectors to work like this for this, but I'm proposing to, when you have a function that is an object, you can you can send the value message with the parentheses. Not sure if I understood your question, sorry.
My question was essentially why to use two different mechanisms.
No, because this is how, so for instance, is I have n equal to, I don't know, 25 at random. Okay, and then I have gamma of n equal n minus 1 factorial. This is in most Smalltalks, this is not Smalltalk code, but in my Smalltalk, this is Smalltalk code. And this is how mathematicians write the equation between regarding these very specific functions. So if so this is true for every n. So here we are expressing something in Smalltalk using exactly the same notation as in mathematics. So for a mathematician that is capturing mathematical knowledge in Smalltalk, it becomes very apparent and intuitive to express the same formula in Smalltalk than in mathematics without having to translate, because the translation will change your mind in some ways, will impact your thoughts.
Okay, thank you.
Now, Guillermo, yes, thank you.
Yes. So I have two quick questions. I hope they are quick. So the first one is regarding the modularity of the. So you extended the syntax, yeah. So how extensible is this? So can I have a parser where I actually load your extensions and then boom, suddenly I have my parser plus plus. So that is one question. So what do you think would be the mechanisms to achieve that? And the second one is, now you have a lot of experience writing a lot of mini languages and composing them together. And I was wondering, from your experience, how could you, or what are the mechanisms or tooling that we need to, for example, to manage that mess? Because suddenly you will have conflicts between those languages. And do you need tooling? What do you need to handle that? So,
okay. The first question is, every class, usually in every Smalltalk, has a chance to configure the compiler just before a new method is about to be compiled. So when the system is about to compile a method, it gives usually, or should give, the class the opportunity to say something. So in this case, for instance, you can, I've implemented, like, you can define which selectors will be valid as prefix, for instance. So I'm only using this. In mathematics, there are many others, but in this image I have, or this class in Boolean, I have only this, the negation. So this is a kind of modularity, because this will impact only the Boolean class and its methods, and not everywhere. This is one thing. The other thing is that there is no conflict between languages, because there are several extensions. But if you think of those extensions where you inject a foreign language, this section of the foreign language is enclosed between tags that identify that language. So it becomes a foreign node in the parse tree that cannot mess with other nodes in the same parse tree. So you have to be careful with other notations that are more global, if you will, like the possibility to write, to evaluate objects that are functions with parentheses instead of the value message, or having unary symbols, which are traditionally binary, because that could create a conflict, because these definitions are more global. But it's actually very easy, because when you send, so for instance, take the case of a unary symbol, which you expect to be binary, like factorial, okay? Which in binary doesn't make a lot of sense, but assume you also want to say, I don't know, the binary version of factorial to be not to start at 1, but to start at the argument, for instance. So now you can think of factorial, the unary version of factorial, as sending, as using an optional argument. If you don't provide any argument, then the argument is nil. Otherwise, is the argument you provide. It is actually the sender who defines the number of arguments it will use. So it is up to the sender to decide which version of the selector it will use. And you can have both. You can, in the paper, there is an example where I implement this exclamation mark as a binary selector on the class size of error. So you can say error and give it a string for the message. And you can use the same in the unary factorial of number, which expects no arguments. Is in the paper.
We have a quick question from Mr. Pimas.
Well, it's two quick questions, I hope. So one is if you have, it's an implementation detail, maybe, have you thought about nested different syntaxes or nesting different syntaxes, like maybe mixing JavaScript and inside there put something else? And the other question is if you have thought, because there's a talk about music later, if you have thought about writing syntax for music.
Okay, so no, I haven't found any in case where there is a need to nest different languages, because even though I use this thing for multiple examples, I always try to maintain the minimum of extensions to very critical things that deserve this distinction. So I don't think for me it would be a good coding style to nest things. But you could do that, but then you depend on the other language. So it's a matter of how you model the foreign AST. The other question was?
If you have thought about writing a special syntax or implementing a special syntax for music.
Well, of course, after Stephen's paper, I started thinking that that could be an option, but it's for him to tell. Not for me, I'm not a musician. But I would like to add that all the work that is presented in the paper is not something I invented like in the last few months. This is something, most of this work has been used for real by several professional developers in an industrial application written in Smalltalk. So these are all proven things, but are only the things we have found in our work. So I'm not trying to go beyond what I really need. Music is not my thing.
Well, thank you, Leandro. So I think we are over the time. Maybe we should stop recording if you want, but there is one further question from Boris. So yes, I don't know if you want to stop recording now and then do the question or the other way around.
No, Boris, please ask the question.
Well, actually, I have two. I was just struggling with this Zoom thing, how to raise my hand in this new client, and then Carlos helped me. Thank you very much, Carlos. One is the difference between being just simply the annotation being just more convenient or more beautiful, which is in itself very important, because that's you feel inside you when you're writing, you feel a different thing when you have the kind of notation you want and you like, and you feel it's beautiful, and this is exactly how you want to write it. But Iverson says something interesting in his seminal work on APL, is that non-trivial knowledge, or there's a difference between being simply more convenient and beautiful versus bringing in new knowledge in a non-trivially new notation. And that latter results when the notation reflects non-trivial structure? Well, for example, a most important structure for computer science is the semigroup. So you have A, B, C, and it's associative. So you group A and B, and you get this new object A, B, and then you tack on C on it, and you can omit parentheses. And it's more than just omitting parentheses. When you can omit them, you are actually expressing that I am dealing with a semigroup here. So how much in this, as you just said, of a decade or decades of doing this, how much have you found relates more to, you know, convenient or beautiful notation versus how much of that started or turned out to express non-trivial new knowledge?
Yeah. Okay. So there are some examples that I need that have to do with the low-level things that requires to write, for instance, primitives in Smalltalk, where you have to express them and think about them. There is a lot of reasoning because there are several tensions. You have to decide which primitives you want to implement, because some primitives you must implement in assembly, let's say, but some others it's just to increase the speed of your system. So there is a tension there of where to put the limit. In that case, for instance, here there is another extension I didn't mention in the paper, which is these pseudo variables, like this one is not an instance variable, is something that will instantiate when you lazily, when you execute this code, and will become an assembly. So you express here in this kind of assembly similar to what Jan has, and each of these is in turn corresponds to actual, in this case, Intel assembly instruction, right? So, but I think that, so in these cases, writing this in some other way, like using traditional Smalltalk syntaxes, creates so much noise that would prevent you from seeing with clarity with what the many things you have to resolve. What is a primitive, what is not, where the primitive is well implemented, how far it is from the hardware, how general if your intermediate representations. There are many things that conjugate that that require a lot of clarity, because there are many factors impacting on this very method and the way and the workings of the system. At the same time, I'm a mathematician, so for me, beauty is essential. I mean, no research, no new knowledge, no deep thinking happens if there is no beauty. And so this is the way to shape your definition of beauty, which might be slightly different from mine, but it has to do with expressing things in a way that when you read them, they tell you things that you didn't know when you wrote them at the beginning. So there is this reflective property that Smalltalk has, where you take some knowledge, you capture the knowledge, you express the knowledge, and this is knowledge that now can be computed, gives you back in all the stages of the process. When you start thinking of modeling, when you start creating classes and methods, when you define the DSL syntax, and when you debug and execute these things, all these multiple layers will give you back a lot of feedback that will create what we call learning or understanding. Actually, will happen in your mind. So, but beauty is essential. This is for me, this is beautiful. But
right. So what you're saying is that this barrier that Iverson is talking about, or this distinction, is not really a barrier, or is not a distinction, because beauty is no less essential than what Iverson is talking about, expressing new structure, or
yes, it's not that there are two. I don't see these things as separate. When someone, when a mathematician is trying to prove a theorem, that's what they do, and suddenly they see the reason why the theorem is true. What they feel is emotion. Is a very
yes,
strong
yes.
emotion, and is the manifestation of beauty. And this is very clear for me and for many people. And for someone with, if you go and Google the gamma function, you will see this very same formula. So sometimes beauty comes from identifying two things that end up being the same, like beauty and understanding, and are tied to recognizing the relationship between two things that were disconnected when you started looking at them. So this is the aha moment, which is an emotion.
Thank you. And the other question I had was about the function application notation. I have been struggling with this, that needing this, because if you look at in machine arithmetic, all the proofs, they're littered with value, colon, value, colon, value, colon, and this is probably like 90% of the noise is that. On the other hand, we discussed this in the mathematics Slack, that small talks, you said this once, that small talks right to left order, where you say X, F, is much more internally consistent than the modern mathematics books, where G circle F is G after F, and for a specific reason. Now, the problem is that I find where things don't compose is exactly when you write XF. The problem is F is a selector, right? It's a symbol, not an object, which goes back to Juan's question, right? So you cannot say X, F, G, because now F, G is not a composition G after F.
Yeah, exactly.
Right? They are not associative, and so function application, so functions do not form a semigroup. And what's worse is, well, really XF is not just an application of F, it's a partial, it's a sand, right? So the object X is a partial sand because it incorporates state, and it's this residual type in clause, right? And that is a huge complexity. Whereas when you just do F value X, it's a simple thing. It's a function application. There is nothing more fundamental in mathematics than function application. Have you somehow struggled with that, or got any solution to that?